Hey everybody. Today we're doing a couple of example problems involving confidence intervals for proportions. Here are the two problems we're going to do. Problem 1. A survey of 275 randomly selected American adults finds that 29% drink coffee. Construct a level 90% confidence interval for the proportion of all American adults that drink coffee. So remember the basic structure for a confidence interval for a proportion. P equals P hat plus or minus Z star square root P hat times 1 minus P hat over N, where P hat is the sample proportion, N is the sample size, and Z star is the critical Z value corresponding to the level of confidence. And of course, P is the population proportion that we're trying to estimate. In this case, we're given that P hat is 29%, N, the sample size, is 275, and that Z star is 1.645. That's the critical Z-score corresponding to a level 90% confidence interval. And we can get that using technology or a table of values, for instance. Plugging in all those values, we get that P can be estimated as 0.29 plus or minus 0.045. Remember that the last number, the 0.045, is representing the margin of error. Approximately 90% of the time that we make a confidence interval like this using these same techniques, we'll capture the true population proportion within that interval. Problem 2. A researcher wishes to study tea drinking in America. How large a sample is needed to guarantee a margin of error of no more than 4%? The margin of error, E, in a confidence interval for proportions is given by E equals Z star square root P hat times 1 minus P hat over N, as we saw a couple slides ago. Solving this for N, we get N equals Z star squared P hat times 1 minus P hat over E squared. If we had some preliminary data, we could estimate P hat that way and plug in here. In this case, we don't have any information like that, so we need to use the most conservative possible estimate for P hat, which is always going to be 1/2. Plugging in P hat equals 1/2, Z star squared equals 1.645 squared, and E equals 0.04, we get N equals 257.03. Remember, we should always round up when we're computing the minimum sample size needed for a particular margin of error. If we ever round down, we're potentially increasing our margin of error and exceeding the bound that we've set for ourselves, in this case 4%. Overall, we can conclude that a sample size of N equals 258 is required.